3. Example 3. Dom, can you read to me example 3?
3 cards.
Stop. How many cards?
3 cards.
Now, 1 card I solve by counting. 2 cards is a tree. 3 cards, I'm not a big fan of a tree unless it's all the same event. Keep reading.
Are drawn without replacement.
That's important. That means this is going to be dependent. It means the odds are going to change because on the second draw there's 51 cards. On the third draw there's 50 cards. Keep going.
From a shuffled deck of 52 cards, what is the probability that all 3 are spades?
All 3 are spades. You know what? Since this is the same event 3 times in a row, I think I can visualize a single branch of the tree. Now, if I was writing this in notation, I would say, okay, they're asking me to find spade 1 and spade 2 and spade 3. And what I'm going to do, Kyle, is draw a tree, but not the whole tree, because the entire tree would have 2 branches, then 4 branches, then 8 branches, and it'd be big. I'm just going to draw the branch that I'm interested in. There. Spade on the first. How many spades are there in the deck? 13 out of? Then, you got a spade again. How many spades are now left in the deck? Out of? Then, that's a 51, not a 57. Then, you got a spade again. How many spades are now left in the deck? 11 out of 50. Because it's the same event 3 times in a row, Brianna, I think I can just visualize that single branch. Now, if they had said 2 spades and 1 non-spade, understand that could be spade on the first, non on the second, spade on the third, or spade, spade, non, or non-spade, spade, or all these different combinations. Did I say combinations? I would handle it with a bucket later on. We'll get there. So, based on that, what am I multiplying together? More specific. 13 out of 52. And Mr. Dueck. Yeah, Zach. I notice you're going down by 1, going down by 1, going down by 1. Would there be a shortcut out there with like the factorial trick? Yeah, eventually. But it's a shortcut that I only use if it's a lot of cards. For 2, I find the amount of time it takes to do the factorial trick and the amount of time it takes to draw the tree are about the same, and I'm good at trees. For 3, because it's the same event over and over and over, you can see I could visualize just that 1 branch. But certainly if they had had more than just spades as an outcome, yeah. Coming down the pipe. Example 4, next page over. It says this: randomly select 1 bill from pot A and 1 from pot B. And it wants the probability of getting a $10 bill on each draw, a $10 bill on only one of the 2 draws. Okay, we have 2 events, pot A and pot B. How many events? 2. Matt, I think I'm going to try doing a tree. Okay, so I'm going to have pot A and on the next level, pot B. What are the possible outcomes for pot A? What can I get? Okay, so 0, 10, or 20. What's the probability of getting a 0? 1 in 3. What about a 10? What about a 20? 1 in 3. Remember the built-in error check that I gave you, Mackenzie? Double check, adds to 1. I didn't miss anything. Okay. Then I can have 0, 10, 20, 0, 10, 20, 0, 10, 20 in pot B. What are the probability of getting a 0 from pot B?
1
1 out of 4. What about a 10? 2 out of 4. What about a 20? 1 out of 4. Now, down the middle branch, I got a 10 from pot A. Given that I got a 10, what's the probability of getting a 0 from pot B? Yeah. There's my 2 10s. See it? This time I'm weighting the branches. Now, I could have done 4 branches, each of the same weight, but I said now I can put the actual probabilities as measurements on each branch, and it's way less work. Is that okay? By the way, down this branch, you got a 10 first. Given that you got a 10 from here, what's probably getting a 0 from here? Don't overcomplicate it. Still 1 out of 4. What about getting a 10? What about getting a 20? 1 out of 4. Down this branch, you got a 20 first, right? Okay. Given that you got a 20 first, what's probably getting a 0 from the second one? Then? Now, what do you notice about these 3 branches, these 3 branches, and these 3 branches? They're independent then. That's how I can tell. What happened on the first row had no effect on what happened on the second row. That to me, Darian, is the best visual description of independence. That I can spot easily. The mathematical ones are much more complicated, but that screams out to me, oh yeah, it didn't matter which branch you went down. But also, how many outcomes are there at the bottom, Darian? 9. This is about, maybe 12 is about as much as I'd go with. This is almost becoming an unwieldy tree. Certainly if I had gone 4, 4, and 4 on the bottom, this would be a yucky tree. But now I can weight the branches. All right. Event A, or question A says 10 from A and 10 from B. Right? A 10 on each draw. Which branch or branches is that? I think I'm going to mark up my diagram. You guys don't bother because I can erase after. I'm pretty sure we're talking about only, right? Right? Multiply down. There's your and. What am I going to multiply? 1/3 and 2/4. Which is, if I go top times top, bottom times bottom, 2 out of 12, and I know that's 1 out of 6 in lowest terms, but I've told you I usually don't reduce to lowest terms unless I have to. Ty, can you give Giancarlo an elbow for me? Yeah. Okay. Giancarlo, then can you do me a favor and read B to me?
A $10 bill on only one of the 2 draws.
Okay. A $10 bill on only one of the 2 draws, and I assume a 0, nothing on the other. Which branch or branches is that?
It's either A or B.
Ready? This branch here? This branch here?
No.
What about this one? Let's put a little check mark underneath here. This branch here? Here?
Yes.
Any other branches have exactly a $10 bill and nothing? Okay. Then it's going to be multiply down, add across. Now, I'm going to show you, first of all, how you would write this in probability notation. And as I'm writing it, notice how it fits on the tree. Here's what you would really say. This is saying find the probability of 10A and 0B, or find the probability of 0A and 10B. That's how they could write it in probability notation. This is why I'm not a big fan of the formulas. I think the tree is much more visual. Can you see what the first branch is? Mackenzie, what am I going to multiply? Yep. Now, by the way, careful. This one here is 10A, 0B. So 1 out of 3, right? And 1 out of 1/4. What does or mean? What does or mean? By the way, look up. Remember, they could also write this as union, which to me is confusing, but I'll put that there just so that we know. Yeah? Oh, I'm sorry, not 1 out of 14. Let's try that again. So a 10 on A, and then a 0, 1 out of 4, right? Is that okay, Darian? Yep. Darian, what's the next branch? 0 on A, which is what as a probability? 1/3, right? And what? 2 out of 4. I think it's going to be 1 out of 12 plus 2 out of 12. Dare we do some fraction math in our head and say the answer is 3 out of 12 or 1/4? And you can try that on your graphing calculator, but it works. Candy for Darian. Example 5. A die is rolled how many times? Maybe I can do this with a tree, maybe not. 2 I can do with a tree, 3 might be yucky. What's A want? Find the probability of what, Mac? A 5 on, you know what? Since it's the same thing over and over, I think I can visualize the tree. It's going to be 5 on the first. What's the probability of getting a 5 on the first? A 5 on the second. A 5 on the third. What's the probability of getting 3 5s in a row? Or 3 6s in a row? Or 3 1s in a row? Or if you really want it to be clever, it's 1 out of 6 cubed.
1 out of 216.
It's at 1 in 216. So you guys know that I roll the dice of fate for the detentions, and if someone rolls a 6, the kids, oh, well, you get 2 6s in a row. Well, the odds of 2 6s in a row is 1 in 36. The odds of 3 6s in a row is 1 in 216. It happens once in a while, but not very often. Okay. B is a little more interesting. What does B want me to find, Matt? Can you? What does at least 1 5 mean? I'll give you a hint. 1 5 or 2 or. So one way to do this would be to find the probability of getting 1. But the problem is getting 1 5 means miss, make, or miss, make, miss, or miss, there's all these possibilities. What did I write as a hint? What's the opposite of at least 1 5? Think very carefully. What's the opposite of at least 1? If at least 1 means 1 or 2 or 3, what's the opposite of that? None. Think about it. Right? The opposite, the complement to at least 1 is none. So, an easier way to solve this is going to be and this is where the complement can come in very handy and save you a shortcut, because the complement has to add to 1. So what's the opposite? What's the complement of at least 1? Nothing. So you ready? What's the probability of not getting a 5? 5 out of 6. And, sorry, let's be consistent in your colors, Mr. Dueck. What's the probability of not getting 5 again? And what's the probability of not getting a 5 again? Whose phone? Yeah, I heard a phone from over here somewhere. Brandon? We're getting our Timbits next class. Excellent. Thank you, Brandon.
You're writing 5 over 3.
5 over 3. I'm writing 5 over 3 instead of 5 over 6 for some dumb reason. 5 out of 6, 5 out of 6. Okay? So, what's the probability of none? 5 out of 6. Can I just go cubed? What's the probability of at least 1? 1 minus that. Which is what? Now you can use your fraction button and whatever. On my TI, it's going to be 1 minus bracket 5 divided by 6. 5 divided by 6. Come on, Dueck. To the third. As a decimal, it's that. As a fraction, is it 91 out of 216? So if someone said to you, I'm going to roll a dice 3 times, I'll either bet you $50 there's at least one 1, or I'll bet you $50 that there's no ones. Which bet would you take?
No ones.
Because there's a 91 in 216 chance of at least one 1, which means the bigger than 50-50 chance that that no ones show up. Okay. Card questions. I like this question, I like this question, I like this question. You're absolutely going to have card questions where you pick 2 cards. You're also eventually going to have card questions where you pick 5 cards or 7 cards, but then I'll give you the shortcuts. Mark, can you read to me, please?
2 cards.
How many cards?
2.
3. Keep going.
Are drawn without replacement.
Okay, without replacement means the odds are going to change. By the way, if they said with replacement, it would just be out of 52 on every single branch, and there would always be the same number of same number of black or same number of spades or whatever the condition was. Okay? What do they want me to find? The probability what?
Both cards are black.
Okay, let's do a tree. I think my tree is going to look like this. Black on the first, not black on the first. Black on the second, not black on the second. Black on the second. He already has, thanks. Not black on the second. Really? That joke was that good? Okay, note to self. Let's fill in now. Let's weight the branches. By the way, we call this a weighted probability tree because you're not leaving the branches blank. It's not out of 4. You're going to be, I know there's 4 outcomes, but it's not going to be out of 4. You're going to put fractions on each branch. So, how many black cards are there in the deck when we start out? 26 out of? So it's going to be a 26 out of 52 and a 26 out of 52. Double check, do they add to 1? Yep. Down the left branch, now this is black on the second, given that you got a black on the first. So down this branch, how many black cards are now left in the deck? 25 out of? How many non-black cards are left in the deck? Double check. Do those 2 branches add to 1? Yep. Down the right-hand side, you got a red card. And by the way, I could have gone B and R for red because not black is red. Anyways, down the right-hand side, I got a red card. So here, given that I got a red card, what's the probability that the second card is black? How many blacks are left in the deck? Out of? How many red cards are left in the deck?
25.
Out of? Are these 2 branches identical? Well, they have identical fractions, but are the fractions in the same spots? Then you know what? These are dependent events. They are not independent. There's to me, the best check. Now, let's answer the questions. A, what do they want? Okay, in notation, that's going to be B1 and B2. And I'm showing you the notation just in case the textbook or the workbook gives you a question like that, so you can translate. But I'm not using the formula to solve. I'm using the tree. Which branch is both black? What am I going to multiply together?
26 out of 52, 25.
Which is what?
25 over 102.
Someone double check, is that right?
Yep.
Yep. But you guys are okay using the fraction button? Yes? Okay. B. Brianna, can you read B to me, please, kiddo? Okay, which branch or branches is at least one card?
B1, B2.
Is this branch here at least one card? In fact, it's got two, which is at least one. What about the next branch? What about the next branch? What about the next branch? No. How could I find this then? What's it going to be? Well, this times this, or this times this, or this times this. What does or mean? Anybody see a shorter way that I could find at least one without multiplying three separate branches and adding them together?
26 times 25 over, so 26 over 52 times 25 over 51 times 26 over 52 times 26 over 51
No.
squared.
Let me ask, I'll give you a hint. Give you a hint. Does anybody see how I could use this branch to figure out the answer? What? It's the complement. Look. Is that what you said too? I heard it there. I didn't hear it. I'm sorry. At least you're awake. Okay. Look, if I have all three of these, which is fine, you could go this, or this, or this, multiply down, add across. Or, Amrit, you could say, you know what, since this is the only thing that's not part of it, I could go 1 minus none. Because the opposite of none is at least 1. And it's way faster. 1 minus 26 out of 52 times 25 out of 51. Which is what? And this is where, Laura, the complement really can start to shine. And it's also, I hope, kind of visual. I got a check mark underneath 3 of them. Well, what's left over is 1 minus. Because the whole thing, not just each branch, the whole thing also has to add to 1. Which is what? What is 1 minus that? 77 over 102. Anybody else? Yeah? Oh. Okay, I'm going to erase my check marks. You guys can just scribble them out. C, exactly 1 card is black. Which branch or branches is that? First, second, third, or fourth? Ah, exactly 1 card is black is those 2. Multiply down, add across. Now, in notation, and we'll write this, it's really saying black on the first and non-black on the second, or non-black on the first and black on the second. That's really what we're saying, Zach, in the notation. Are you hopefully seeing why I prefer the tree to the notation? The notation gets kind of cumbersome to me. I mean, I understand, okay, yeah, we're saying black miss or miss black. But the tree, it's screaming out at me. Boom, boom. Hey, well, let's fill it in. Black on 26, 20, oh, come on, pen. Don't tell me my pen stopped working here. Bear with me, it hasn't done this for a while. So, yeah, we are back. 26 out of 52 and 26 out of 51, or 26 out of 52 and 26 out of 51. Now, this is what Dom was suggesting earlier as a shortcut. He had noticed that we were getting the same fractions to appear. You could certainly go like this. You could certainly say, well, it's 26 out of 52 times 26 out of 51. And then you could say the second fraction is identical. I'm just going to times by 2. And I think you get 26 out of 51 when all is said and done. Okay. Can I use the same tree for question D? Really? I heard a second phone go off now. Where was that from? Kind of over this way. Well, we're going to keep an ear out. If you see anybody suddenly shuffling into their pocket to try and adjust a phone or into their purse to try and fix the phone, you let me know. Keep an eye out, folks. Back to my question. D, can I use exactly the same tree for D? Nope. But how many cards are we picking in D? Okay. You ready? D is very tricky. Is it Darian shuffle? Are you the one who's phoning it? Well, we'll find out. Rachel, Sterling, you guys are on it, okay? Ashley, can you read D to me, please?
The first card is a 3 and the other card is a 3.
Okay, put your pencils down. I'm going to do this wrong. It's a very subtle wrong, and so I want you to see if you can spot it when I draw the tree. Can you read it to me again, Ashley? What's it want? And so a lot of students will go like this. They'll go, oh, queen on the first, not queen on the first. And they'll say, don't write this down. How many queens are in the deck? How many queens are in the deck?
4.
Out of? So they'll go 4 out of 52 and 48 out of 52. And then they'll say, what does it want for the second card, Ashley?
And the other card is a 3.
And so they'll say, come on. So I wait for Dropbox to finish its updating. My back. So then a lot of students will go, okay, 3 on the second, not 3 on the second. And they'll say, how many 3s are there in the deck? And they'll say, oh. And then they'll say, okay, that's the answer. Oh, and then they'll say, how many 3s are there in the deck? There's 4 out of 51, and they'll say 44 out of 51, and out of 500. Come on, out of 51. Guys, stay with me, please. And here they'll go 4 out of 51, and 47 out of 51. Can you read it to me again, Ashley?
The first card is a queen and the other card is a 3.
What's E? Can you read E to me, Ashley?
One of the cards is a queen and the second card is a 3.
It's this second one that gets very tricky. This first one, because they've specifically told me the first card is a queen, I can say, okay, and that's a queen followed by a 3. That part of the tree works for part D. Scroll up a little bit. It's this second one here that says one of the cards is a queen and the second card is a 3. That's a bit trickier. And the reason is this card here, which is not a queen, could have been a 3. Could have been a 3. which would mean I wouldn't have 4 3s left. I would have, okay. So how the heck do we fix that? This part is okay. 4 out of 52, 4 out of 51, 47 out of 51. I have to take into account 3 on the first, other. So you ready? How many 3s are there in the deck? We've pulled out the queens, we've pulled out the 3s. How many others are there? We've pulled out 8, so what's left? Now down this branch, down the other branch, you got queens and 3s still left in the deck. Here, let's go queen on the second, not queen on the second. Oscar, what did we get down this branch? What's right here? Yeah, I saw you looking at your phone. What did you get? Unless your calculator works sideways somehow. I don't think it does. What did we get down this branch? What did I write right here? A 3. So we picked a 3. How many queens are left in the deck? Not meant to be a trick question. We picked a 3. How many queens? 4 out of? We picked a card. Okay. And how many non-queens? 47 out of 51. I don't care about this branch over here. I'm not even going to bother filling it in because E didn't give me that option. E says 1 queen, 1 3. D says a queen followed by a 3. Okay? So D, a queen first, 4 out of 52, followed by a 3, 4 left out of 51, is going to be 16 out of 26, 52, or what is that in lowest terms? Four out of 52 times 4 out of 51. I know in my head that that's 16 out of 250, 26, 52. Is it 4 out of 663?
Yes.
Compare that with E. I'm going to put a check mark underneath the branches that satisfy E, which says you got to have 1 queen and 1 3. This branch works. What other branch works? Branch number what? Counting from the left. That branch works.
Does it do?
Yep.
Why does that one work if it says the second card is the 3?
Oh, one of the cards is a queen. I'm sorry. You know what happened? I think I mistyped this, Mr. Dueck. I think what I meant to say, one of the cards is a queen, and the, can you cross out the word second? Thank you, Ben. Other card is a 3. Let's make it that way. Note to self, fix this. And that's why this second branch works. Okay? Sorry. Which is going to give me, down the first branch, 4 out of 52 and 4 out of 51. Or, and down the second branch, oh, in this case, I get identical fractions because there happens to be 4 queens and 4 3s to start out with. That won't always be the case, but certainly because it's the case this time, I could just type the first fraction, hit equals, and then just go times 2. Right? In fact, I think it's going to be 8 out of 663. I took the top fraction, times it by 2. F. And then we'll get into the formula, and then we're done. F. Laura, can you read F to me, please?
Both cards are equal.
How many cards? 2, and you know what? Since it's the same, let's see if we can do this without a tree. It's going to be, visualize it in your head. Ace, ace. You see the branch? Ace, ace. See it? Ace, ace. How many aces are there? Oh, let's write it. This is going to be ace 1 and ace 2. Ace, for you guys, it's this ace. How many aces are there in the deck? Out of? So we start out with that. And you just picked an ace. How many aces are left? 3 out of? So although I've harped on the tree, maybe, Chelsea, for the same event twice in a row, you might be able to just imagine that branch and walk down it all in your head. And if you can, great. But you could also draw a tree, ace, not ace, ace, not ace, ace, not ace, and fill in all the branches. That's perfectly acceptable as well. It's going to be 12 out of 2652, which is 1 out of 221. Is that right? Mm-hmm. Not very high. Well, which is good, because getting 2 aces in a row should be unusual. That's the tree. Now what about the formula? Okay. Using the formula. Now, here's what we have. The probability of A and B equals the probability of A times the probability of B given A. This can be rewritten. Can you get that by itself? How would I get that by itself? Physics students, this should be old hat to you.
Do you want the BA over?
Okay, so another variation is why'd you do that, Mr. Dueck? Well, Dominic, what are they asking me to find in part A? Okay, that vertical line means given. You know what? I said they're asking me to find that. Maybe they gave me this thing and maybe? Maybe they did? This is where the formula comes in handy. Brendan, can you give her a little elbow for me? She needs your love and help. You're back? Mm-hmm. Ah! No, nothing? I missed. Oh, I got Mackenzie right between the eyes. Gah! I'm sorry, my aim was off. I thought I was hitting there and nothing. Okay? So another way to take this equation and use it formulaically is to get any one of these by itself. So probability of B given A, well, that's going to be probability of A and B over the probability of A. Did they give me A and B? What? Over? I think the answer is going to be a half, but double check me. Okay. Use your fraction button on your calculator. By the way, how do you divide by a fraction? You multiply by the reciprocal. So this is really 1 over 4 times 2 over 1, which is 2 over 4, which is 1/2, in case you're wondering how I did it in my head. Okay. What does B want me to find? Okay. They're flipping this. So, given A, put an A down there. You know what? It's going to be this. And over B. What? Look up. Here, A is the given one, and it's and over A. Here, B is the given one. The pattern is going to be and over B. And that's honestly how I memorize or use this formula. This formula is called conditional probability, and Darian, when I taught it to my grade 12s, I always said it's going to be both and over the given one. That's how we memorized it, because the letters confused the heck out of me, but I can figure out what letter comes after the vertical line. That I can spot. What's and in this question? Over. What's B in this question? What is 1/4 divided by 1/3? I think 3/4, but double check me.
Yep.
Oh, Rachel's coming up in a second, but not yet. A or B. Okay. Or as a formula, what did or mean? Minus was add minus the overlap, right? Did they give me the probability of A? What's the probability of A according to this question?
1/2.
Or did they give me the probability of B?
Yes.
What?
1/3.
Minus, did they tell me the probability that both could happen at the same time? What?
1/4.
1 out of 4? So apparently the probability of one or the other or both is going to be that. There's where the formula can be used. I guess, Jake, the formula is advantageous when you don't know what the events are and you just know the numbers, the data. Okay. What is 1/2 plus 1/3 minus 1/4? Do that one in your head, Mr. Okay. It's going to be 6 out of 12 plus 4 out of 12 is 10 out of 12 minus 3 out of 12 is the answer 7 out of 12? Thank you very much. You've been a good audience. I can do fractions. The math F word, not the F word you're thinking of. Fractions. Last one. Where can we apply some of this? So this can be used in decision theory. In fact, there's a whole branch of math called actuary math, which insurance companies used. So I've made up a question with Rachel passing or failing a test, but an insurance company, if they're insuring you, would be, okay, probability of you, how susceptible are you to getting cancer or not? How susceptible is your house to being flooded or not? How susceptible is your house to being, they use this all the time. This is how they set their rates. Okay? So, Rachel, can you read this question to me, please?
The probability that Rachel will pass math this semester is 0.75.
And you should be offended by that. I lowballed you, but keep going.
And the probability that she will pass English is 0.9.
Also, I lowballed you, but keep going.
Assuming these events are independent,
No, each one does not affect the other.
find the probability that she will pass.
Okay. How many events are there? How many subjects are there? 3. Okay. Math, not math. English, not English. English, not English. Rach, what's the probability that you'll pass math?
0.75.
What's the probability you'll fail math?
0.5.
Right? 0.25, is that what you said?
Yeah.
Double check, it adds to 1. And we used the complement there as a trick already. We probably could have done something, but yeah, let's subtract. Okay, now it says they're independent, so it really doesn't matter which branch we go down. What's probably pass English? 0.9?
0.9. Oh, sorry, 0.9.
What's probably that you fail English?
0.1.
Now, down the other branch, you flunked math. What's probably that you'll pass English? It says they're independent, so it's also 0.9, 0.1. Now, you could argue with me that it's more likely if a kid fails one course that they fail a second course, and I would be willing to have that argument. But for the numbers that I made up, and of course, Rachel, we know that the answer actually on both these branches should be 100% and 100% that you're going to pass both of them. But we're making up numbers here, okay? Okay. What's the probability she'll pass math and English? Which branch is that? First one, 0.75 and 0.9. Which is what? 0.675? What's the probability she passes math or English? Which of these branches is math or English? Second and the third, I disagree. First, second, because remember, or also means both. Okay? So that one, or that one. Wait a minute. Can someone see a faster way that we could do it? We could go multiply down the first, multiply down the second, multiply down the third, add. Or we could give Rachel a compliment. Rachel needs a compliment. What kind of a compliment could she give Rachel? Could we give Rachel 1 minus what? 0.25 and 1 minus flunking both. See it? Which is what? Yep. You did this? You have an answer?
Oh, no.
Oh, you're playing with hair number 93? Okay. 0.975? And again, I just made up a dumb example with courses, but again, replace passing math and English with a house out on the prairie somewhere, and instead of M, think flooded or not flooded. And instead of E, think earthquake or not earthquake. And now you can see where insurance companies would find this very, very valuable to figure out what kind of a rate they'll quote you based on where you live. Okay? Or look at health insurance, where they would look at the history of health in your family, and they would say cancer or no cancer, rare disease or no rare disease, or whatever. And this is how they would quote you your health rate, your health insurance rate. Absolutely, this is used all the time. Math, but not English. That's this branch here, right? 0.75 and 0.1. I think that's going to be 0.075. D, neither. Can anybody tell me how you could get the answer to D from that number there without doing any other math? So yeah, it's going to be 1 minus that, which is also going to be the same as multiplying down that branch. Both of those are about the same amount of effort. So what do we get?
0.025.
Okay. What's your homework? Those there. Page 152, numbers 1 to 5 and 7 and 8. Also, any of the other stuff that nobody has asked me about yet. I'm probably going to do a homework check Wednesday. You guys got a long weekend coming up? Mm-hmm. I'll do a homework check Wednesday, and you know what? I'll probably send a yucky email out to wreck your long weekend that Wednesday night if you don't have all the homework done, caught up.
What do we have in terms of
What do we have in terms of, sorry, let me pause the video.